Why is feature extraction key for dimensionality reduction? Imagine trying to find your way through a crowded room filled with hundreds of objects. It's overwhelming, right? Now picture having a map that highlights only the most important landmarks. That's what feature extraction does for data. It picks out the most meaningful parts of a dataset, making it easier to understand and work with. In machine learning, especially in unsupervised learning, datasets often have many features or variables. These high-dimensional datasets can cause what's called the curse of dimensionality. This means models struggle to find patterns because there are too many features relative to the number of data points. It can lead to slower processing times and less accurate results. Feature extraction helps solve this problem by transforming the original features into new, smaller sets that still contain the essential information. Think of it like condensing a long story into a few key points. Techniques like principal component analysis, or PC, do this by finding new features called principal components. These components are uncorrelated and capture the maximum variance in the data, meaning they hold the most important information. Another method is autoencoders, which are neural networks that learn to compress data into a smaller form and then reconstruct it. They can capture complex, nonlinear relationships that simple methods might miss. This makes autoencoders especially useful for images and other complex data types. Feature extraction is vital because it improves efficiency. When you reduce the number of features, your algorithms run faster and requiring less computing power. It also helps in visualizing data by projecting high-dimensional data into 2 or 3 dimensions, making it easier to see patterns or clusters. In applications like image processing, feature extraction helps in compressing images and identifying key visual elements. In natural language processing, it transforms words into vectors that preserve meaning, making it easier for models to understand text. In data visualization, it turns complex data into simple, understandable graphics. However, there are ethical considerations. When reducing dimensions, some information might be lost. If that information is critical, it could affect decision-making, especially in sensitive areas like healthcare or finance. Also, automated feature extraction can introduce biases if the training data isn't diverse enough. In models like ChatGPT, DALL-E, or Midjourney, feature extraction helps process vast amounts of data efficiently. It allows these models to generate high-quality text and images by focusing on the most relevant features. So, in the end, feature extraction is a key step that makes high-dimensional data manageable and meaningful, helping machine learning models perform better and faster.